Hello, I welcome you all to your own channel MSQ Learning. Now, as you remember that in the previous video we discussed about the dimensional analysis, and we see the two methods by which we can generate the problems with the help of the dimensional analysis, that is Relay methods and Buckingham pi theorem. So in previous class we already discussed in detail about the Relay methods, and we see one working example that how to generate a relation with the help of the Rayleigh methods. So now in this video we will see the Buckingham pi theorem. So as you know that Buckingham pi theorem is used when the number of variable is more than the fundamental variable, or you can say that when the number of variable is more than 3 to 4, right? Then using the Rayleigh method is quite complex, right? Or it's somewhat difficult, right? So to overcome that difficulties we have to use the that modified form which we call it as a Buckingham pi theorem. So in Buckingham pi theorem basically you have to find out the pi terms, right? And then write down the dimensional relations, okay? And then again you have to find out the arbitrary power values, and then later on you have to substitute into that equation and then get the dimensional relations, right? So what is the Buckingham pi theorem and how to find out means how to solve the problem with the help of the Buckingham pi theorem, and all those things we are going to discuss in this video. So here we have that Buckingham pi theorem means if there are n variable in a physical phenomenon, and if these variable contain m fundamental dimension, that is MLT. As you remember, actually fundamental dimension we can say that MLT, but there are the fundamental dimensions we have before, but we are not dealing with that what we call the heat transfer problem, where you have to deal with the heat transfer problem. There you must have to consider the temperature, but in fluid mechanics problem we don't consider the temperature, so we are neglecting the temperature. On basis of that we can say there are the three fundamental dimensions in your fluid mechanics problem, that is mass, length and time. So then these variables are arranged in n minus m dimensionless term, and each term is called as the pi term. So whenever you have to find out the pi terms means you need to know that how many variables are involved in your problem, and then how many fundamental dimensions. So in fluid mechanics problem the fundamental dimension is fixed, which is 3, and if you are dealing with the heat transfer problem then you have to consider the fundamental dimension as a 4. All right. So first of all you have to find out the pi terms. After finding the pi terms you need to know that what are the variables involved. So here we have that let x1, x2, x3, so on, so xn are the variables involved in physical problem. Let x1 be the dependent variable and x2, x3, so on, so xn are independent variable on which x1 depends. Then x1 is a function of x2, x3, xn. So you have a total variable, we can say x1, x2, x3, xn, and in which the x1 is a dependent, means it's depend on the rest of the variable like x2, x3, so on, so xn. So we can say x1 is a function of x2, x3, so on. So if you remember that force is equal to mass into acceleration, means the total variable involved in this relation, that is 3, but force is a dependent and mass and acceleration are independent. So it means that you can say the force is a function of mass and acceleration. So you have a you can express this relation in mathematical form, that is x1 is equal to f of x2, x3, so on, so xn, and f1 is f1 of x1, x2, so on, so xn is equal to 0. First of all you have to find out the pi terms, right? So how many pi's you have got, right? So let's say f of pi 1, pi 2, so on, so pi n minus m, whatever the n minus m value we have, that is the pi terms, right? So you can write down this equation in the dimension form, that pi 1 is equal to x2 a1, x3 b1, x4 c1, so on, so x1. Again pi 2 terms is you can write x2, x3, x4, a2, b2, c2 and x5. If you look at this sequence, then you find one thing common, that is in each pi terms, that is x2, x3, x4, x2, x3, x4, x2, x3, x4 are repeating, means x2, x3, x4 are the repeating variable, but x1 is a non-repeating variable, x5 is a non-repeating variable, and again the xn is a non-repeating variable. Means that when you write down the pi terms you have to select some variable as a repeating and some variable as a non-repeating, right? So then only you can simplify the problem. After that each equation is solved by principle of dimensional homogeneity, and values of a1 and b1 are obtained by this relation, that is pi 1 is equal to phi of pi 2 pi 3 so on, so pi n minus m, right? And then again you can say that this pi 2 is equal to pi 1 pi 2 so on, so pi n minus m, right? So now that what you will do, that you can pause the video and write down this statement, right? Then you have a, that is just now I told you that while we writing the pi terms, right, in terms of the arbitrary power, there is some repeating variable we have chosen. So how to select the repeating variable, that we have methods, right? So method of selecting the repeating variable. So as far as possible, the dependent variable should not be selected as a repeating variable, like f is equal to mass into acceleration. So f is a dependent, so f will not be the repeating variable, right? Then the repeating variable should chosen in such a way that one variable contains geometric properties. Geometric properties I mean to say the length, diameter and the height, and one variable contain flow properties like velocity, acceleration, right, angular velocity, angular acceleration, so on, so. And the third variable contain fluid properties like you have a density, viscosity, right, vorticity and dynamic kinematics, all those things. Okay, now so these are what we have. A geometric properties means length is L, diameter D, height H. Flow properties means velocity and acceleration. Fluid properties means viscosity, density and flow properties, that is vorticities, right? So this is what you have a theoretical way for solving the dimensional problem with the help of the Buckingham pi theorem. Means first of all you have to find out that how many variables are involved in the problem, and then you have to see that you have to find out the pi terms, and then you need to select the repeating variable and then write down those pi terms and equate these dimensions and find out the arbitrary power, and again substitute into that equation, you'll get the relation. So this is what we will see. We try to understand this whole concept with help of the one working example. So the problem on the screen, please write down that the efficiency neta of a fan depends on a density rho, dynamic viscosity mu of the fluid, angular velocity is omega, diameter d of the rotor and discharge q. Express neta in terms of dimensionless parameter, right? So what we have, one problem is there, that is the efficiency of a fan. A fan is there whose efficiency you have to find, means that you have to generate the relation for efficiency of a fan, and that efficiency is depends on the density, dynamic viscosity, angular velocities, diameter of the rotor and discharge. So we have to express the phi, that is phi is denoted by neta in terms of the dimensionless parameter. So here we go again, that this is what we have a problem. So yes. That you can write down here, that solution. Okay, no, so that neta is a efficiency, is a function of what? It is a function of density rho, dynamic viscosity mu, angular velocity is omega, diameter d and discharge q. Now so now we can find out that total variable is how many? 1 2 3 4 5 6. You have to include all, that dependent and independent both, right? So now we can write, that is this mathematical form you can write neta is equal to function of rho, mu, angular velocity is omega, diameter d and discharge q. All right, then further you can write this in another format, that neta is equal to f1 of rho, mu, angular velocity is omega, d and q. Let's say is equal to that is not here equal to, so is equal to 0, and this is the equation 1. All right, so this I'll show you that neta of sorry, that this is what is the mistake I did, right? So this we can write, that is f1 of, why? Because we are including this all terms. So neta, rho, mu, omega, d and q is equal to 0, and this is your equation 1. All right, now Then you can count the total number of variable, that is 1 2 3 4 5 6. So now we can see here that yes, so now we can say the total number of variable is, that is total number of variable, right? So total number of variable is variables n is equal to 6, and the fundamental variable, as I told you in fluid mechanics problem, the fundamental variable is 6, right? And the fundamental variable, that fundamental variable variables, that is we are denoting by m, which is 3, right? Now we can find out the pi terms, right? So then these are the we can say the step how you will execute. So number of pi terms, right? So number of pi terms, that is pi is equal to n minus m. All right, so that is 6 minus 3 is equal to 3. So how many pi's you got? That is 3 pi, right? So that on basis of that, the equation 1 can become, so now we can say the equation 1 can be written as why? Because all the variables we have converted it into the pi terms, and how many pi we got? That we got the 3 pi's, right? So the equation 1 we can write in this format, that is f1 of pi 1, pi 2 and pi 3 is equal to 0. Let's say this is your equation 2. All right, now then what we will do, we have to select the repeating variable and the non-repeating variable. Actually the 3 pi's is there and the total variable is 6. It means that out of, you have to split the number of variable in such a way that the three variables will be the non-repeating. So as you, how many pi's is there, that many non-repeating variables should be there, right? So as the 3 pi's there, means 3 variable you have to select in such a way that should not be repeated at all, right? So it means that out of 6, the 3 will be the repeating variable. So again we'll come to the problem and then we'll see that what we can choose. Actually you have a variables are these are, that is this is here I'm showing that these are the efficiencies, density, viscosity, angular velocities, diameter and discharge, right? So now what I'll do, that we have a methods of selecting the repeating variable. So these are the method of selecting the repeating variable is what? The repeating variable. And one more thing, that first we have a point is that as far as possible the dependent variable should not be the selected as a repeating variable. So what you will do, that you cannot choose this neta as a repeating variable. Why? Because it is a dependent variable which depends on this 5 variable, so it should not be the repeating variable. That it means that out of 5 you have to select the 3 repeating variable, right? So this one is selected as a non-repeating. Out of this you have to select 2 repeating non-repeating, right, and 3 repeating variable. Again for repeating variable we will see the second statement, that the repeating variable should chosen in such a way that one variable contains geometric properties, right? So first is what? That out of this geometric properties means diameter. So this I have selected as a repeating variable, right? Now the second one is the contains flow properties, means what? Acceleration, velocity and all those things, right? So here you have a what are the flow properties, means angular velocities, it comes under the velocities. So we have selected the second repeating variable as the angular velocities. The third is what? The third is the you have a contains flow properties, right? So flow properties means density, viscosity and all those things. So now here we have there is a contradiction, that this is also the flow properties and this is also the flow properties. So always you will give the priorities to the density only, right? So this I am considering it as a repeating variable. So my repeating variable is diameter, angular velocities and the density, and the non-repeating variable are efficiencies, viscosity and the discharge, right? So here we go again, that we can write, so we can say choosing d omega and density as repeating variable, as repeating variable. All right, repeating variable. So as we have chosen the repeating variable, so we will write down the pi terms, that is pi 1 term is equal to what? That is d to the power of a1 and omega to the power of b1 and rho to the power of c1 into neta. First I'm taking this one, and then pi 2 terms is equal to d to the power of a2 omega to the power of b2 and rho to the power of c2, right? And you can select anyone. Let's say that I'm taking this mu, right, that is viscosity, and the pi 3 terms is equal to d to the power of a3 omega to the power of b3 and rho to the power of c3, and this is finally you have a discharge, right? Now first of all, what we have to do, we have to find out the pi 1, pi 2, pi 3 terms. So for finding these pi 1, pi 2, pi 3 terms, we should know the arbitrary power, that is a1, b1, c1. So once you get and substitute, you will get the pi 1 term. Similarly, pi 2 and pi 3. So for finding this arbitrary power, that is a1, a2, a3, b1, b2, b3 and c1, c2, c3, you have to write on the dimensions, right? So now here I am going for the first pi 1 terms. So pi 1 terms is equal to that is d to the power of a1 omega to the power b1 and rho to the power of c1 and neta. We will write down the dimensions, that is pi is a constant, so its dimension is m power 0, l power 0 and t power 0. D is the length, so it is l power a1, and omega, that is t minus 1 only, right? So this is what you have, a t to the power of minus 1 and b power, this is ml minus 3, that as I told you that you should remember this dimensions formula, right? So this is c1, and this neta is the efficiency, that is output by input, so it is also constant, that m power 0, l power 0 and t power of 0. All right, now then what you need to do, that you have to simply equate for first you have to take m, then l, then t, and then equating this power, right? So first I'm writing for m, right? So here it is what 0 is equal to, here don't have a m, m is there, m power c1 have a 0, so we can say c1 is equal to 0. First arbitrary values we got, right? Now then for l, that you can write for l. Okay, so for l, how it is, that is l power is what here 0, right? L power a1, l power is minus 3c1, so you can say that is 0 is equal to a1 minus 3c1. So c1 is equal to 0 from here, so you can say a1 is also 0. So again you got, this is a1 also, right? Now then we have a for t, right? So for time we have a power is 0, power is minus b1, we don't have a t, so we can say 0 is equal to b1, right? So that is minus b1 plus 0, you can write like this. So this is b1 is equal to 0, right? So a1, b1, c1 for pi 1 terms we got. Now we can find out the pi 1 here itself, right? So what is the pi 1 actually? The pi 1 is nothing but you have written d to the power a1 omega b1 rho c1. So a1 0, b1 0, c1 0. So something power 0 is 1, right? So it means pi 1 is equal to, you have a neta directly, right? So you can write down this here, that is pi 1 is equal to d to the power of 0 and omega to the power of 0 and rho to the power of 0 into neta. So this is what e to the power of 0 is 1, that means pi 1 is equal to neta. Let's say you find out the pi 1 term. Similarly we'll go for the pi 2 terms. All right, so here show you that pi 2 terms is what, that pi 2 is equal to d to the power of a2 omega to the power of b2 and rho to the power of c2, and this is the mu, right? So pi is a constant, its power m power 0, l power 0, t power 0 is equal to l power a2 t minus 1 power of b2, and this is m l minus 3 power of c2, right? And this mu is nothing but ml minus 1 t minus 1, right? So this is ml minus 1 t minus 1. Okay, so power 0 first we have for m, we can say for m, right, this is what 0, and this is, we don't have a m here, we don't have m, we have a m c2, that is equal to c2, and here we have a plus 1, so this you can write that is c2 is equal to minus 1. Okay, now then again you can write that is for for L. Okay, so L power is what, here we have a 0 is equal to L power is a2, right, and L power is minus 3c2, and L power is minus 1, right. So c2 is minus 1, we will substitute, it is minus 3 plus 3 and minus 1, that is what is called plus 3 minus 1 is plus 2, so a2 is equal to 2. All right, so this simple maths you have, that's not math, that 1 and 2 is standard math, right. a2 is equal to 1. Then you can find for t, right. So for t is what, that is power is 0 minus b2 and that minus 1, so we can say 0 is equal to minus b2 minus 1, that is 1 is in this side, so b2 is equal to minus 1, right. So we got again the pi 2 terms we can write in this format, that is dA to the power of 1, so d to the power of 1, b omega b, that is omega to the power of minus 1, rho to the power of minus 1, right, and this is what you have a mu. So pi 2 terms we can write, that is pi 2 is equal to mu d a2 is equal to I'm sorry here, that is a2 is equal to 2, right, a2 is equal to 2, so this is a2, that is pi d is a2 is equal to minus 2, that is c2 is minus 1, am I right? Right, just hold on, d to the power, okay, a2 is equal to a2 minus 3c, so a2 minus 3c means, okay, yes, minus 2, so this is what you have a pi minus d2, right, this is what you have a minus 2, so this will be the there is a mistake actually, right, so mu by d square omega into rho. All right, yes. Then next we have a, finally you have a pi 3 terms, right, so pi 3 is equal to what, that is dA3 and omega b3 and rho c3 into q, right, so pi equation is m power 0, L power 0 and t power of 0, right, that is equal to L power of a3, t power of minus 1 to the power of b3, and this is m L minus 3 power of c3, and this is discharge, that is L cube and t minus 1. All right, so here for m we can say for m, that is for m, this its power is 0, right, so is equal to, we don't have m, mc3, right, so that is c3 is equal to 0, first we got. Okay, then we have a for L, that is for, you can say L is equal to, here we have a L power 0, L power a3, L power minus 3c3 and 3, right, so we can write it here, that is a3, right, minus 3c3 and plus 3, very carefully you say, so c3 is 0, so it will be 0, a3 plus 3, that is a3 is equal to minus 3, right, so a3 is equal to minus 3. Again for t is equal to, that is this is t power 0, we have a minus b3 and minus 1, so here we can say 0, right, that is 0 is equal to what we say, 0 is equal to minus b3, right, minus 1, so it is 1 will be bring this side, so b3 is equal to minus 1, we got, right. Now then we can say find out the pi 3 terms, that is pi 3 is equal to, we have written here a3 omega b3 rho c3 q, so a3 is equal to what, a3 is equal to minus this one, that is d to the power of minus 3 omega b3, that is omega minus 1, and rho c3, that is rho power 0 into q. So this is 1, so we can write this pi 3 terms is equal to q by d cube into omega. Okay, right. So now pi 1, pi 2, pi 3 terms we got. We can substitute this value of pi 1, pi 2, pi 3 in equation 2. Okay, so just hold on, let us show you here only. Right, so we can write down this, that is substitute pi 1, pi 2, pi 3 in equation 1, in equation 2. Okay, so when you substitute that equation 2, which is nothing but the f1 of pi 1 is what you got, neta, and pi 2 is mu by d square into omega rho, and pi 3 is this one, that is q by d cube into omega is equal to 0. Right, so again you can say that neta you have to find. So neta is equal to, when you bring it this side, you have to multiply with one what is called proportionality constant. That proportionality constant, I'm taking it as a phi, so it is equal to mu by d square into omega rho comma q by d cube into omega. All right, so this is your solution. So this is how with the help of the Buckingham theorem we can generate the relations. Thank you.